Good afternoon, everyone. Welcome again to the Mozilla Dev Room, and I'm pleased to introduce Jean-Yves Perrier, who's going to speak on reading WebIDL.
Thank you. Hello, everybody. Nice to be back in Brussels, and for once it's raining and not snowing. So I will speak about WebIDL today, and I will just explain a little bit who I am. So I'm working for Mozilla on the MDN, which is a documentation for developers. I'm based in London, and I sometimes participate in terms of events, so that's always nice to meet other people. MDN last year got 10 years old, so it's the 11th year of the developer documentation at Mozilla. So the developer documentation was there earlier with working on a non-wiki website. So MDN, as we see, it is a kind of library of the web university. It's all the guide, all the reference you need to write a website. It has about 60,000 documents. About 15,000 of them are in English. And we have about 20 active languages and locales on the wiki, with 7 of them very, very active with edition every day. It is a wiki, and that's quite important. That means that if you see something missing, something error, you just edit it. And most religion and all religion are reviewed more or less deeply, even though it's a kind of religion, but we usually every day scan about what has happened over the last day in order just to check that everything is okay. When you write a website, usually you use 3 languages, and I call them the 3 musketeers. You have HTML and about 120 elements. You have CSS with about 400 CSS properties. And you have JavaScript. JavaScript 6 is about 800 pages. And we always see the web pages, the website as using these 3 things. But if you remember the story in the novel, the 3 musketeers weren't 3, there were 4. There was D'Artagnan coming and meeting them and having fun with them. And it's exactly the same for the web. You have HTML, you have CSS, you have JavaScript, but you have all the web APIs. And JavaScript and web APIs are 2 different things. You can have JavaScript, the language, and use it in another non-webby context, and it will not have all the methods, all the properties, all the interface that you use to access a page. For example, if you use Node.js, you use JavaScript, but you don't have access to the web API. You have the Node.js API. Similarly, we can imagine a web where we will not use JavaScript. We will use the web APIs. It's something that has been tried where Internet Explorer in some older version were able to accept VBScript. By chance, it fell down and didn't succeed in this area. But the 2 things are really unrelated. Of course, JavaScript is used to access the web API in the modern web. But the 2 things are distant. Web APIs are written and are in JavaScript most of the time, but they are independent of JavaScript. That means that in order to describe them, what they will do, what the web API is doing, you don't need to use JavaScript. And in fact, if you look inside the specification, they are using another language called WebIDL. So WebIDL comes from far long ago, in the 90s, another millennium, where to describe interfaces, the OMG decided to create a new language called Interface Description or Definition Language. It depends on the version. And this has been used to middleware, into middleware like Crowbar or XPCOM That means that you describe how a system is working, but you don't constrain it to a specific language. You say, okay, this will work like this. But to access this, I will not telling you you have to use Java, you have to use C++, you have to use JavaScript. And CORBA, for example, was used in numerous, and is still used in numerous systems. And over the years, it has been accessed with C++ programs, then with Java program, and probably now with even other kind of languages. IDL has a big drawback. It's very, very complex. It is designed to describe any kind of interface. So it has numerous keywords. It allows parameters that can be read, write, and so on. So that's very complex. And in the web, in the spec, we decided to use something simple, which is called WebIDL, which has a W3 specification, which is based on IDL, but not exactly the same. So it's something much, much more simpler that is applied to the web and only to it. So the advantage of WebIDL is we can see it in two ways. First, it's independent of the actual language. It's independent of the specificities of JavaScript in our case. And second, there are more information in it that than you can put inside the JavaScript language by itself. So just by reading the spec and the WebIDL description of an API, you will have more information than by just reading the name of the functions inside JavaScript. And this is something very, very interesting for all the people that are not actually writing the spec, because the browser maker needs to know all these details to make an interoperable version of the API. The doc maker, like us, the writers, need to know this so that they can tell you, okay, this method will create a new object. And finally, web developers need it in order to understand exactly what will happen. So, let's have a look. So this is an example of an interface taken from the spec. It's a performance API. And it's described in WebIDL. For those of you who are familiar with C++ or Java, this is very similar to .h header file and interface files in these two languages. Of course, it's completely different keywords, but it has a similar structure. And it's normal because this language has a kind of interface definition inside them, which is something we don't see much in JavaScript. So if we look a little bit at this, we see that an API is defined with a keyword interface, which is quite logical, with the name of the interface, which is its type. And you can have several of them for one, just by adding several with the keyword partial, which doesn't change anything for the user of the API. He sees only one big API. But this changes and simplifies the spec, right, the work of the spec. Because if you write a new spec that extends an API, you can just add partial and you don't have to care about how all these things will go together. So that's quite practical. Here we see for performance, there was first performance.now, and later the spec added other elements. Sometimes it's even used in the same specification. That way, one part will only describe the first part, and the second part of the spec or third part of the spec will describe the rest. So here I have another more simplified example of a spec for speech synthesis. This is part of web speech, where we see this interface. We see something here which is an extended attribute that, in fact, in this case, tell, okay, this lives behind this preference in Gecko. This is a Gecko-specific extension. And you have here three attributes, three properties that are all name, pending, speaking, and prose. All are Booleans, and all are read-only. So this is the kind of thing that you get via the interface. The definition of a property is quite more powerful than this. You also have, so we have seen the access control, we have seen the return type, but for example, just by adding the question mark, everybody doing a regular expression sometimes know the meaning of the question mark. It means that it's optional. That means that the method can return none. If it is not there, it can never return none. It's as easy as this. Also, we can say if some operation will throw or not. Will there be exception? So set a throw means the source attribute can send an exception when we try to put a value in it. There is also getter throw. It's much more less often on web APIs, but it's the same. You can get an exception when you read the value. For example, if the interface is not, or the object is not correctly initialized. Other things like new object, for example here. This says that buffered, each time is called, we return a new time range object, a different one each time. So if you, in your program, your JavaScript program, you call it 5 times in a row, you get 5 completely independent time ranges objects. This is used in case where, like this one, you want to have a set, okay, what has been, for example, loaded in my video that I will play. So I can use a buffer and I know exactly what is buffered at this exact moment of the time, for example, for this one. And these kind of things are really important for the people writing the documentation. I have here with the HTML media element buffered, that it's a read-only property, it returns a time range, and it's a new time range. So each time you call it, you get a new one. And this allows the two things to go inside the documentation. Another thing that can be communicated through the API is this API available, or even this property is either this method, are they available in workers? So the time where we had only the main thread where every JavaScript was executing is over. Now we have plenty of other threads and other workers around there. But not all the APIs are suitable to work over there. For example, Canvas cannot be used in a worker. You have to use a special interface which is called off-screen Canvas that just landed in browsers. In this case, you see that the performance, the main one here with the now, is available to the window context, but also to any worker context. But the rest of the performance interface is only available to window. You cannot use this inside work. And this is really simply indicated. If there is nothing between window, no worker. Methods. We have seen properties until now. Methods is the same. It looks classical in the way of writing these things. For those who know the IDLs, you will notice that you don't have the in-out indicator because it's always in for WebIDL. So you have the method, you have the return value, and you have the parameters. And interesting, some parameter can be defined as optional with default value. It's very simple. Here again, we see that we can define if an exception is raised by the method. We have throws. Of course, with a method, you don't have to make get and set different beast. You have only one beast, so you have throws. Then comes some more, not complex, but more nifty features. So when you write your specification, you want your object to be often serialized or stringified. And instead of using the method that is used in JavaScript, there is a generic way of saying it. So if you want to define toString, you say stringify. And that means that the toString method will be added in JavaScript. This is done because if you map to or bind to another language, maybe there will be a different feature than a toString. Similarly, if you want to serialize and have a toJSON, you call it serialize. Gecko has an old version of it, which is called JSONifer, when it was first proposed. Then, of course, the name has been changed because it was a bit too close to what is produced and not to the semantic. But this goes even further. You can say that your new interface is an iterable object. And just by saying this, by saying which kind of key you will have, which kind of value you will have, automatically this means that it will have an entries method, a value method, a key method, a for each methods, and automatically it will work in for off. This is very easy for the spec writer. A lot of these things then are automated for the browser maker, so it doesn't need to write all of this in all detail most of the time. It has, of course, to make some binding behind the scene. And to read inside the spec is very easy. On the other side, this is quite complex for the user, because the user knows JavaScript, and he doesn't want to know that iterable will create all this. That means, for example, in the documentation, in MDN, we translate. We will never say that, okay, this interface has iterable. We will say this will have entries, values, keys, and for each, but we will say inline to for off. Another similar beast is setLab. I think form data is one of them. You have an interface that represents something like this. So just by saying this, again, you have entries, values, keys, and for each, and add, clear, and remove that are associated with this. And in some other language, in JavaScript, maybe you will not use this, but something different. Interesting here, add, clear, and remove are only added if the setLive is not read-only. If it is read-only, of course, these methods are not created and are not associated. Another construction that is needed is you need to construct an object, and you use a constructor. And in several languages, constructors are just specific methods. But in fact, they are a different beast. So WebIDL allows you to create constructors or to define constructors. And there are two types of constructors. Unnamed constructors, which means, in fact, they will have the same name as the interface. For example, here we have constructors, meaning, okay, I have a constructor, it will be called new message channel, no parameter, and func message enable means that only if this function is called with a true, this will be enabled. It works in window and worker. So you have your unnamed constructor. Similarly, you can have several of them. Here we have an example. The URL interface has two constructors with two different sets of parameters. You can also define constructors that has a different name than the interface. As far as I know, that's the only place in the whole API of the web where this happens. Maybe there is a second place, but you have HTML image element, which you expect to have either the constructor called the same, but in fact the constructor is called image. So if you do new image, you get a new HTML image element. So where do you find these WebIDLs? You find them in every specification, and every browser vendor has them public. So I've put here Gecko. Gecko is very practical for this because there is a directory where there are all the WebIDL. You find them in Chromium and WebCore. Here they are next to the implementation of each interfaces, which means you have, if you want to get all of them, you have really to go to each directory and extract them. And Edge also publish all of them in one big directory. Edge does also something very nifty. They have a special WebIDL that explain all the difference between Internet Explorer 11 and Edge, all what they have removed. So that's pretty cool. Each vendors have a little bit extended the ideas. They have created extended properties that are not understood by the other, but are very useful for them. WebIDL has been invented with this in mind, so it doesn't make the WebIDL incompatible with them, between them. They are still compatible with them, but there are things that are just not installed on the other browser. That way they were able to put more semantic and also to put semantic information that is relevant only to one engine and not to the other in the implementation data. Also, all browser has a different set of, a different level of implementation of the different API. Ideally, they will all have everything implemented, but sometimes they have notice bugs, they have a big trouble, but they can provide some of. Here is an example in Gecko. This is extracted from here. We see that, oh, okay, there is a bug. Effect shouldn't be read-only, but for the moment it's read-only. So by accessing the different WebIDLs that are provided, you can quickly check the availability of something, or if something is not working, or maybe there is a bug. And the bug is known and written inside the WebIDL. So we have these different dialects. So if you want to go more in detail with this is only the overview. There are about 300 keywords that can be added to tell different elements inside WebIDLs. And if you want to go forward, more in details, there is a spec which is quite easy to read. There are also a few other documents. Each vendor had created one of them for the special version of the WebIDL that they are using. They are all listed here in this URL, but the URL is so long, so I have shortened it here. And just to finish, I would like to just to say that if you write an API, don't forget about putting as much semantics there, because it helps both the browser maker, because they can use it to know, okay, and to write better tests and to implement it better. They help the web devs that have this information in a handy way once they are able to read the WebIDLs, and they don't need to go through tons of textual documentation that can be quite difficult to read. And they are also useful for .writers because it's very easy to translate it into plain text. So thank you. I don't know if you have any question. If not, oh, yes, sorry.
Is there a for WebIDL, and is there also a tool which you can use to check the implementation?
There are plenty of parsers existing. I've used one WebIDL 2. It's called WebIDL 2. It's for Node.js. It works pretty well. Sometimes you need a little bit to strip a couple of things from one vendor or the others. As far as I know, there is no. It's something that is dreamt by a lot of people, but as far as I know, there is not yet a tool that makes a test with the one that are on the spec. It's sometimes difficult, in fact, to extract all the WebIDLs from the specs. They are easy to read inside the text, but to get all of them from the different spec in a big chunk and then make a generic comparison with the browser is quite difficult, because some spec use the old way of doing the things, and some other are the new shiny CSS of the spec. So this is a complex part, but theoretically it's absolutely possible. Any other questions? Thank you.